Hello, I am Rui Cardoso, Senior Lecturer for Aerospace Engineering. This face you are seeing there is my face, and I'm going to introduce you to statics. So I'm going to show you some sample lectures and tutorials on statics. So if you want, for some reason, to email me with any query, you have my email address here. You also have these Instagram, Snapchat, Facebook, Twitter, things for Brunel, which you can try to follow. So what I'm going to cover in these sample lectures and tutorials is basically material for your year 1 at Brunel. So I'm going to cover statics only. Of course, you are going to do many other things, but the main topics I would like you to focus is basically the first three: vector analysis. I'm going to give a very quick review of vector analysis with the basics. And then I'm going to move to equilibrium of a particle, where a lot of vector analysis is required. Then I will introduce moment produced by a force vector. So these are quite basic but extremely important concepts that you need to know very well for the remaining of your lectures. Then I will move to the equivalent system force moment, where you will learn how to basically build an equivalent system that is in the same equilibrium conditions as the original system. That will be very important for the topic that follows, which is equilibrium of rigid bodies, which is the main topic in statics. We will study many different types of supports. The bodies or the rigid bodies, they need to have supports. They cannot be levitating in the air. And then we are going to learn how to replace those supports with forces, which are called reactions. And we are going to learn how to derive the equilibrium equations. Basically, these equilibrium equations will make sure that your body is in equilibrium. And then from those equilibrium equations, you can calculate many different unknowns. Then we will talk a little bit about beams. We will derive the transverse shear force and bending moment diagrams for beams. So this is a kind of introductory video I will have for all these sample lectures. Of course, different lectures will have this same introductory video, but they will refer to different topics on this table of contents if you want. Another thing you can, if you are more curious, I have a YouTube channel which you can, if you are interested of course and curious, you can try to see what I have there. So I have a lot of lectures in that YouTube channel, so you can search for that channel by googling Rui Cardoso YouTube. I have lectures for more advanced years, so I recommend at this point you not to see those lectures. But I also have some supporting material for statics in year 1 there in the YouTube channel. So I think is a nice thing for you to see as well. I would like also to say that all the examples I will be doing in these lectures and tutorials, not all of them, but many of them were taken from these recommended books I have listed here in this slide. So Engineering Mechanics Statics from Ibler, or from Vector Mechanics for Engineers, Statics from Beer and Johnson, from Engineering Mechanics Statics from Marian, Bolton and Craig, and also from my own book, Stress Analysis for Lightweight Structures, a MATLAB-oriented approach. So all the examples you will see in the videos, sometimes I refer which book I've taken the example, sometimes I don't, but these are the books that I follow. So in case I forget to mention which book I took the example, you have here the list of books, so you know where they came from. Right, thank you. So we will move now to the specific lecture. Let's start. Good afternoon. Is this working? So let's do this example today in the afternoon. We have only 1 hour. So everything we have been doing so far is just to build the equivalent system force moment at a point. We are not writing the equilibrium equations yet, right? So at this moment, the only thing we are trying to get is to replace the original system with forces applied at different points. Like you can see here in this example, you have a force F1 applied at point A and a force F2 applied at point B. So we want in this example to replace this system with an equivalent system with a force and a moment applied at point O. So the first thing I'm going to do is to obtain the resultant of the forces. Basically what I have to do is in this case I have two forces, so that resultant is going to be equal to force F1 plus force F2. I have the vectors of these two forces. So I can continue here. Force F1. The x component is this one, 10. Agree with me? So I will have 10 in the x direction. The y component is this minus 15. So I will have here minus 15 in the y direction. And the z component is this minus 40. You can see here, we talked about this last week. You can see minus 40 is multiplying a unit vector, k, which has a norm 1 and gives me the direction of my z-axis. We talked about this last week. I uploaded today in Blackboard some notes on vectors and tensors, where all of this is detailed there. You can go and check. So the z component is minus 40. And this is my force vector F1. Right? I need now to add my force vector F2. My x component of this F2 is minus 15. My y component is minus 20, this one, right? Is the component that is multiplying the j unit vector that gives me the direction of my y-axis. So minus 20. And my z component is minus 30, right? Is this one, minus 30. And that will give me my vector F2. You see? And now, the only thing I have to do, I just need to add this component. So starting with the x component, I have 10 minus 15 is minus 5. Looks basic, but you have many mistakes in these kind of things, right? So we have to do it very slowly so that you are following. So minus 35, minus 70, right? This is my resultant of my forces, R. As you said, is not difficult at all, right? Now,
Let's calculate the moments now. Let's calculate the... We need now to get the moment produced by these two forces about point O. Okay? So let's start with the moment produced by force F1. So we need to define the position vector connecting point O with point A. So we need to have this position vector starting at O and going all the way to our point A. So this position vector, I will call it ROA. And that's what I need to define now here for the cross product. To obtain the moment, I need to do the cross product with the position vector with the force. So you tell me, what is the x component of this position vector, ROA? 0. You think it's 0? You all agree 0? 0. Yeah, it looks like a 0. What about the y component? How much is it? 100. Y 100. The y component is 100, are you sure? It's 250, right? So I want this component here. I'm going to look, this component here is my y component, right? This is equal to this 250. You agree with me? Yes. So 250 here. What about the z component? Z component, I'm looking for this one. What is this component here, right? Is my z component. You all agree? How much is it? 100. Now I need to do the cross product with the force vector F1. And force vector F1, we have it already here. Is this one here, right? So I can just copy is 10 minus 15 minus 40. Okay? So I can write like this. This is my position vector, ROA. And this one is my force vector, F1. But that is only the contribution from force F1. I need to add now the contribution from my force F2 for the moment. So for the force F2, I need now to get the position vector connecting point O with point B. It's always a good idea to draw these position vectors because you need to get the components of these vectors. Right? So this is going to be my position vector, ROB. I need to get the x, y, and z component of this vector. You tell me the x component. How much is it? 150. Good. Y component? 0. 25. It's not 0. Look, you have here this 25, right? That will add a component in the y direction, right? You agree with me or not? So it's 25, right? 25. And the z component is 40. Very good. Right? And now I need to do the external with my force vector, which is this one here. My F2 is this one. We are already. So I'm just going to add it here. Minus 15, minus 20, minus 30. So this is my ROB. And this one is my F2. Right? You all agree with this? So the only thing I have to do now is the cross products, and then I get the moment. So let's do these ones. So I'm going to do it here. So I'm going to continue here, okay? So MO. So let's start with the first cross product, this one here. So my X component is this times this minus this times this. So it's going to be minus 250 times 40. Minus with minus is plus 100 times 15. Let me write this. This is 250, right? Y component is, the Y component is this cross product, this times this minus this times this is my Y component. So it's going to be 1000 minus 0 is 1000. Okay? And the Z component is this times this minus this times this. We are always doing the cross product. That's why we call this cross products, okay? So it's 0 minus is minus 2500. So this is the result of the first cross product. Now we need to do the second cross product. Is minus 2000. You are saying this last one?
Minus 1,000. Yeah, minus 1,000.
Yeah, is this times this minus this times this? Oh, for y. So let's see the y. You are saying 1,000 here. Okay. So you have to do this cross product. This times this minus this. In the y direction, you change the signal. Right? That's why. I had some questions in the morning. If you can do the cross product in a different way, like doing the determinant of a matrix, you can do it. It's up to you. What I want is just the cross product properly done. It doesn't matter if it is like this, like we are doing here, or if you have a different technique to get the external cross product. It's perfectly fine. You know what I mean? So just get that right. Now let's do the second one. The second cross product. Then we need to add. So X component is this times this minus this times this one. Okay? So that will be minus 25 times 30. Minus with minus is plus 20 times 40. This is the X component. The Y component, you need to do this cross product. So you will obtain minus 40 times 15. Minus with minus is plus 150 times 30. And for the Z component is this times this minus this product here, this cross product. So you get minus 150 times 20. Then minus with minus is plus 25 times 15. That's it. Okay? And then if you do these calculations, you will obtain the... So if you now just add these components, you will obtain the total moment, right? Okay, so... And then, at the end, this means what? This means this means at the end that you basically will replace this system. So basically you will build an equivalent system where you don't have this force, right, applied at these 2 points, but instead of that you will have what? You will have a resultant of the forces at point O, which is the summation of forces at that point. All those, basically this is F1 plus F2, like we did before. And then you will have a moment at point O, which is the moment produced by F1 and F2. So this system with only a force and a moment at point O is equivalent to the initial system with the force F1, F2 applied at point A and B. Right? And the value of this resultant force, you have it here. This resultant force is this vector. And the moment you have at point O is the result of these calculations that you can easily now finalize at home. Okay?